Question 2f. Resistance of bulb B is 120 ohms. Calculate the value of the total resistance of the circuit. So there's two ways of answering this question, the hard way and the easy way. We'll do the hard way first. If we look at question D, we can see that R2 is 40 ohms, and in question E, we can see that R1 is 16 ohms. 16 ohms and 40 ohms. We can see that we have all of the resistances in the circuit, except for this bulb here, bulb A. We need to work out what the resistance of this circuit is. We can use the formula P equals IV and combine that with V equals IR to work out what the resistance is. What we have to do is we have to rearrange Ohm's law so it becomes I equals V divided by R, and then we need to stick that I into this equation here. So it becomes power equals I, so it's going to become V over R, voltage divided by resistance times voltage. So that equation becomes voltage squared divided by resistance equals power. Now we know the power is 0.6 watts. We know the voltage is 8.0 volts. We now have to rearrange this equation so it becomes R equals V squared divided by P. Voltage 8 squared divided by 0.6, 8 squared divided by 0.6 is 106.7 ohms. So we now have all the resistances of all the resistors in the circuit. The first thing I'm going to do is I'm going to combine these two resistances. 120 ohms plus 40 ohms makes 160 ohms. So this here is like one big resistor with a resistance of 160 ohms. Now these two here, the 106.7 ohm and the 160 ohm, are in parallel. The formula for resistance in parallel is this one here. 1 over R total equals 1 over R1 plus 1 over R2, which I like to write as R total equals all of that to the power of minus 1. So R1 in this case is our 106.7 and our R2 is 160. I can simply type that into the calculator, bracket 1 divided by shift answer, because that's stored in the calculator, plus 1 divided by 160 divided by ABC, it doesn't really matter, and then I go to the power of minus 1, so I go hat minus 1, execute, 64 ohms. So is the total resistance 64 ohms? No, because what we've done is we've looked at these two pink resistors. We've said that the 106.7 ohm resistor is in parallel with 160, and we said that those two combined make one 64 ohm resistor, but we still have R1, which is 16 ohms. So R total is really 64 plus 16, add 16 on, giving a total combined resistance of 80 ohms. So that was the hard way. The easy way would be to see the total current from question E was 0.125 amps, and the total voltage must come from the power supply being 10 volts. Then we can use Ohm's law, V equals IR, and we can rearrange it for R, so R total is equal to the voltage total divided by the current total. So it becomes 10 divided by 0.125, 10 divided by 0.125 works out to be 80 ohms.